upwards of 17% of US electricity use might go towards generative AI factories, data centers that are running AI, which blew my mind.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software.
Welcome to the Environment Variables podcast and the Week in Green Software, a regular news review podcast where we break down the stories shaping sustainable software and greener computing. I'm one of your hosts, Tzviya from W3C, joined by our other regular host, Kate Goldenring, as well as our guest, Dave Masselink. Dave has been working as a software engineer predominantly around the renewable energy industry for about 15 years. For most of that time, he's been a front-end web engineer building complex data visualization and command and control systems. He joined SolarCity in 2014 and was on the Grid Systems team when they were acquired by Tesla in 2016. That team built internal and external facing web applications utilizing fleet telemetry and commissioning data. Also control and visualization interfaces for some of the world's first virtual power plants. From 2018 through 2021, Dave was at Intuit, the financial software company, and had the chance to deep dive into cloud ops and automating as much of it as possible for internal developer platform purposes. In 2021, Dave's illustrious career moved to Google's X Labs, which is called Tapestry. He led a team of engineers in building the next generation of utility grid planning tools, including collaborative model editing, routing models in and out of various simulation pipelines, and visualizations to make sense of the resulting data. In 2025, Dave launched Compute Gardener, the Compute Gardener scheduler, making carbon and cost-aware operations simpler and lower risk in Kubernetes environments. They're in early adoption ramp-up with some academic partners now. Dave, I would love to just chat for a few minutes about your really remarkable career before we move on to discussion about the week in green software.
Yeah, I'll also throw a question at you specific to that. I think it seems like you've had a North Star with how you've directed your career and that it's focused on energy and the grid and sustainability. And I'm curious how you've kept yourself on that North Star. I think there's a lot of tantalizing things in tech, and it seems like you've been able to keep that cohesion to your career and ultimately built up to Compute Gardener of your own making.
Yeah, no, that's a really interesting framing. North Star, I guess that's an interesting way of putting it. I hadn't thought of it that way. Really, it's just an interest that I can't shake. And as well, it's the fact that I've gotten many opportunities along some of those stops that Tzviya just mentioned to see how deep, how fractal, how many different opportunities there are for software engineers in and around the energy industry, especially renewable energy. You know, everything from capturing data in a test field to building beautiful data visualizations to something that will help an end user control what's happening with their battery at home. All of these things require software, and yet one thing that I've run across with folks is it's difficult sometimes to imagine what a energy adjacent software role might look like. A lot of folks know about solar and wind and don't see themselves climbing up to the top of roofs or turbines, and aren't entirely sure where their skills would fit into the picture otherwise. But I love having those discussions because the truth is that software skills fit in many, many places. And yeah, I think that's just something that I've gotten to see in my career, and hopefully my career proves at the very least.
Yeah, I think there's two lenses people can take when they hear green software. There's one that's find a software career that works in an energy field that's focused on sustainability. So work on a product or technology or resource that helps make the planet greener. And then there's another lens of green software that's take your traditional software engineering role and how can you build infrastructure and software in a greener, more efficient way. And I think we talk a lot about both. And I
Mhm.
think this podcast will be talking about both, but I also want to ground it in that there's two ways people can approach this consideration of how to be a green software engineer.
I
And it's
love.
choose your own adventure. There's no wrong choice. Sorry, Tzviya.
Yeah, I really like looking at it in those two lenses, and I think that's something that we might want to focus on today is how we can make these things actionable. There's also kind of a running theme in the topics we'll be talking about today, about flexibility, whether that's flexibility in your platforms or flexibility in the grid. And so, yeah, Dave, why don't you tell us a little bit about Compute Gardener?
Absolutely. I'd love to. Yeah, as I stated and you kind of shared as well, a good chunk of my career has been in and around the energy industry. The last stop at Tapestry was building out grid utility planning tools. Um, Essentially, the new generation of planning tools. You both might know that so much of the world runs on emailed Excel spreadsheets, and that's something that I think software engineers like us can fix, and that's what we were trying to do at Tapestry in the grid planning space. But I was starting to get a little frustrated there, being on, I guess, kind of the supply side of the energy world, um, which is a critical space to be. There's these interconnection queues that are backing up, and it is very much the case that utilities need a new generation of tools to be confident in deploying as many renewables as developers want to put out on the grid. That's really the limiting factor at this point. Like a few years ago, it was capital, and then IRA cable log, it wasn't for a while, and there's still questions about political will. But really, I think the thing that is most in need is confidence for the path forward in deploying as many renewables as we think we need, as we want, while having everybody who's been in charge of this century-old world's largest machine, the grid, uh, feel comfortable with that, because there's traditional ways that things have been done. So anyways, yeah, at Tapestry, we're on kind of the supply side. I was watching all of the news that you guys are watching as well about generative AI, the wave that was coming, and feeling a little sad that there was no, there's these cloud hyperscalers, and they're, of course, critical to all of this, but there's really no single entity that is in charge of everyone in the world's cloud compute and making sure everybody's making good choices for the global community. And sure, maybe that's a little bit too idealistic or something that's not going to happen. But at the same time, it was like, okay, there isn't going to be some central entity that can help us globally optimize this. But that's the reason why we need bottom-up tools, tools that any engineer and any team can pick up and start working with today and start to get their team interested. And so that was kind of the goal of Compute Gardener. It's a Kubernetes scheduling plugin. It primarily takes grid carbon intensity as an input, and helps you for any job that you indicate has some flexibility. It will automatically take that and say, okay, let's hold off for a while until we're at a cleaner point in the grid, upwards of how many hours you give it. And then we are building out more right now in terms of forecasting and spatial shifting as well. We've got temporal shifting in place, and building out spatial shifting. And it's essentially, Masheika, you had on a few episodes ago, she had something that stood out to me. She was talking about how she was sick of talking in theoretical terms. That's something that I felt too. When I was working at Tapestry, and even before that, I was seeing the same white papers that everybody was seeing from Microsoft every year about, if we did some temporal and spatial shifting, we'd have 30 or 40% headroom to, let's do this, right? But then the same white paper would come out the next year and the next year and the next year, and it didn't seem like anybody was actually picking it up and adopting it. It was all simulations that they had run, and I was like, this is not rocket science. It is the case that you can pretty straightforwardly pull in an external signal to a Kubernetes cluster, to any compute cluster, and consider it for some scheduling decisions. And if you make it simple enough for a DevOps engineer to install it while they're sipping their coffee in the morning, helm install Compute Gardener. Maybe by the end of the day, they'll come back and be like, 20 grams of carbon dioxide saved. I don't know what that means. But the next day they'll talk about it in their stand-up with their team, and somebody else will say, "Oh wow, we've got that tool now. Let's take a closer look." And so that's kind of my hope in terms of the bubbling from the ground up, because we don't have the ability to institute anything for the top down. That's kind of the motivation, and at a high level, what Compute Gardener is. We're building out that spatial shifting, as well as kind of a back end API to facilitate with a cross-regional and forecasting perspective.
And just to ask a couple questions about it, if it's you mentioned
Please.
that it will basically make sure that you only schedule jobs when it's the right time to do that for energy saving reasons. And I imagine that's because there's peak hours and there's chow hours to the grid. In a Kubernetes context, does this mean you can only use Compute Gardener for jobs, so not long run daemon sets? Rather, it relies on your architecture to have a lot of short lived jobs that are periodically being scheduled and then completing?
That's a great question. It kind of does assume that, or at least probably it works best in that context. It can schedule in pod in the Kubernetes parlance, and so any work that you throw at it could potentially go through the scheduler, but it is very much targeting deferrable workloads, things that you might want to kick off at any point, but don't necessarily need to run right away. So this is probably not inference that has a customer waiting on the other end. This is probably more like a training job that you run over the course of a day or two anyways, and it just needs to be finished by Friday or something. So that's kind of the type of compute job that it's targeting more so.
I'm curious what companies or partners you've been working with that are starting to become interested in this. I think there's probably some pushback you might get from larger corporations that are so used to knowing exactly when something's going to run. Like they set their job to run at a certain time and they're not comfortable with an external scheduler shifting when something runs. I've seen that in my own company, and so I'm curious like what your pitch is to that kind of pushback.
Yeah, it's a very common bit of pushback. I mean, infrastructure risk is felt very deeply by people, or perceived risk, especially when something's working. We've got something deployed in production and it's running. Don't touch it is pretty much the first rule. So that is something that I do definitely experience. The pitch to some extent is around trying to highlight that as a custom secondary scheduler into a cluster, the blast radius, so to speak, is quite small. It's only the jobs, only the pods that are asking to be scheduled by this scheduler that even know that it exists. And beyond that, there's some other circuit breakers or something built into the scheduler where you can make it very simple and just say, okay, scheduler, handle it, and it'll run with its defaults in terms of the grid intensity that it's trying to hit and 24-hour maximum delay. But you also have a lot of control over that, where you can say, actually, this can only delay for a maximum of 2 hours. If you can make it better in 2 hours, good, but otherwise it's got to run. And so that is one thing I'll highlight too, is that because we do have the ability at the end to say, okay, it's been too long, this job really does need to go forward. There is no guarantee actually that you do end up running at a better time for the grid. That is the goal, that's the hope, and more often than not, that's going to be the case. But it's especially with the ability to say, okay, it's got to run soon. It can't exactly be guaranteed at this point either.
That makes sense to give it a guarantee window. And I also liked your example of training. When you're training workloads, it completely makes sense that you'd want to schedule that to off hours, and ideally inferencing requests can happen in the on hours where people are demanding more.
Actually, I didn't answer your question about the traction that we've been getting so far. There's a few small academic groups of professors and their labs that are starting to work with it, play with it, but the wider deployment is in the early days. It is the case that right now, like I said, that there's this perceived infrastructure risk of changing something, touching something. It's working now. Why touch it at all?
I'll also add a note that there is a lot of paranoia and perceived risk that comes from infrastructure teams. I know I kind of double as a software engineer and an infra engineer. I handle Terraform a lot, and I'm very used to handling the resource requests and limits of a pod. And I often get reviews on my PRs that say bump this by 4 or 10. I'm always like, do we really need 8 cores for this workload? And there's always someone who has more of an infra background than me that's been paged a dozen to 100 times more than me that wants higher limits. And I do think there is that PTS, like there is that reactionary feeling from experience that some people have that I don't, that does lead to some of this cautious behavior from infra engineers.
That's a really good point as well. yeah, as we know, in so many places, the incentives haven't always been aligned. Where the incentives for cloud compute or the push it towards it has been developer convenience and trying to potentially limit costs. And so, yeah, one of the challenges is that sustainability isn't always on everyone's mind. It's seen as a trade-off that's being asked of someone to take an action that's more sustainable or have reliability. And really, the pitch is to try to highlight that it doesn't have to be a trade-off like that, especially if we're using tools that give us enough control. And so, I think to some extent, this actually does tie into our first article too, around flexibility and how it's being seen at the utility space. Does it make sense to shift gears and
Please go ahead.
talk about that a little bit? Yeah, so this is an article that I brought from Utility Dive website. It's about data centers being ready to negotiate flexibility for speed. And what they mean by flexibility for speed is speed to interconnect from the utility. And this is kind of the latest article that I've seen in a broader theme around data center flexibility over the last year or so. I think a lot of us have been seeing. And it had some interesting numbers in particular around what actually would be necessary in terms of modifying data centers and their compute and power profiles. So there's an EPRI study, it's a Duke University study that indicates that only a 1% to 2% reduction in most data centers' peak demand could end up cutting electricity rates by 0.5% to 2 to 3%. So not huge mitigation at the data center layer can have a even larger cost implication downstream for end customers. That isn't to say that that's their primary motivating factor, but it is interesting how the two can influence each other. Another thing that I thought was interesting in this article, in terms of just being caught up on all of the stats that are flying around, not that long ago, we were talking about data centers and the IT sector being 3 to 4% of global electricity consumption, maybe roughly about the same in the US, a little bit higher. This article indicated that I think this was an EPRI estimate that potentially by the end of the decade, or even maybe a little sooner, 2027 or 2028, they were thinking that upwards of 17% of US electricity use might go towards generative AI factories, data centers that are running AI, which blew my mind. I don't know how you felt about that. For so long, it's felt like, this is going to be, we're talking about a few percent and it's growing fast, but we still have a long time before this is, or we still have a few doublings before this is really going to be an everyday concern, but we're actually there now.
I feel like we're actually there now is a message I've been hearing for a few months from some of the bellwethers in the industry. This is, we mentioned Masheika. She's been saying this about water for a while. We're actually there now. But in terms of the savings, the cost savings, in many industries, the only way to get people to pay attention, or the only ways to get people to pay attention, are either through their wallets or through their regulations. And the regulations actually is another way of saying through their wallets, because it comes down to fining or lawsuits, because people don't necessarily care if it's the law. And so if there's a way to present sustainability as a way of saving money, then people suddenly start to care. That's what happened with accessibility. People care a lot more about accessibility now than they did 5 years ago, largely because of the European Accessibility Act. And that has directly to do with the fines that are in place.
No, that's a really good point. And it's something that I both lament and also realize we've got to leverage, right? As people operating in the economy as it is. It sort of frustrates me at times that we can't talk about advancing social global goods without saying, okay, how much is it going to cost me and how much actually better will it make me? That's just how the conversations tend to go. But at the same time, I think we got to lean into it. And that is something the Compute Gardener pitch has been refined in that direction as well, especially around recognizing that people don't only want to talk about carbon-aware computing, they want carbon and cost, or a broader sustainability concept for sustainability awareness in their computing. And so that's one thing that we've been building as well. It's kind of called the cheap to green knob, a way to blend and say, okay, in our organization, we can talk about sustainability. Right? We can bring that to the CFO and have that conversation. So let's twist to the green direction. And maybe I'm in an organization where that's a dirty word that can't be spoken, twist it to the cheap direction. The correlation between the two is so strong often anyways, that you're often coming out with a cost benefit in the let's go green efforts, as well as a green benefit in the let's go cheap efforts. So there is a strong correlation. Let's see. I think one of the other things that stood out to me in this article, or just keeps coming up, I guess, in this broader topic, is around flexibility. It's what we're calling this episode, but at the same time, it's a word that means everything to everyone, which is part of the problem, especially at the data center layer, oftentimes, or the data center operations layer. You'll talk about flexibility, and they have a very different conception of flexibility than we might have. We might be thinking, oh, let's shift our compute to a time that's cleaner for the grid, a different place. For in the data center operator world, flexibility might mean let's put a natural gas turbine on site so that we have more flexibility with how we're using the utility power from the grid. So there are different goals and different vantage points on what flexibility might buy you. And so I just wanted to highlight that as a challenge I've faced in having some of these discussions. I'll come into a conversation thinking that we're all talking about flexibility for carbon emission mitigation purposes, and that's often not the case.
Yeah, I think that's a really good point that you made right there. The article, it said, so data centers have like 3 pillars. They can manage their workload, so kind of time shift them so that they're not having as many peaks and troughs, but rather some more like good average usage. They can reduce the AI usage of their plant, or they can use backup, kind of like what you were saying, as the natural gas energy on site. And that third one there makes it so that, from the green software perspective, you have to be careful about wanting data center flexibility, because now what that means is instead of accepting the limitations of the grid, we're using more natural gas resources in order to go beyond the limits that we have. Instead of kind of slowing growth and slowing progress for the sake of stewardship. And so This is where the word flexibility can be dangerous. And I think that was interesting because this article had like 2 pillars that I like and a third pillar that made me a little anxious, whether it's like lithium batteries that our resources are being mined for, or it's natural gas.
Yeah, no, that's a really good point. That I hadn't thought about it that way, as about thinking about, okay, how do I feel about each of the pillars? But I think I would classify it in a similar way, that like, even if it's the case that we're seeing these as the pillars of flexibility, again, we still have different vantage points. And maybe I'm seeing 2 out of the 3 pillars and the third is obscured more often than not.
Yeah, I think like we need to be motivated to build greener software solutions, like using Compute Gardener to change our scheduling. Like if this was an AI data center, they might be more motivated to use Compute Gardener if they didn't have the option of extending their power resources with an on-site backup. Do you know what I mean?
Absolutely.
I completely agree with that. And, this kind of thing has come up before, like with diesel backup during power surges and things like that. This has actually happened in the real world recently. And I don't know how to make that happen beyond things like regulation. But I think one thing that occurs to me, maybe something that we can think about, is like we are always talking about the big data centers, the enormous data centers. There are smaller data centers. How would they deal with a situation like this? Does this concept of flexibility occur in the smaller data centers? And what would flexibility mean to them?
It may well exist in those contexts, and that's probably some of the customers, the projects that are most excited about the possibility of adopting flexibility for grid connection more quickly. Honestly, I think it probably is smaller data centers, smaller compute clusters, where a tool like Compute Gardener is going to fit in first. A lot of the large hyperscalers, they have some internal teams that are tracking the compute energy utilization to some extent, and have some tools that they're working on. But really, at a high level, that kind of bubbling from the ground up tools concept is for the long tail to some extent, because there's for every Google or Microsoft out there, there's hundreds of smaller companies that have data scientists or engineers clicking go on training jobs, hundreds, thousands of them every day, and they aren't going to have the organizational support that they might at Google or Microsoft or Amazon, or just organizational tools to leverage. And so I think that's one of the reasons why I care so deeply about the open source tooling space in sustainability, because it really is going to be the best and maybe only option for that long tail. Another thing that I thought kind of tied into this a little bit was not really an article, but a note that came across from GSF, from Green Software Foundation recently, about the silo, the sustainability interoperability layer for operations. This is a white paper and a companion note that have been published recently. I don't think it's publicly available. I think it's available to the GSF member companies. But at a high level, the summary talked about some of these themes that this last article mentioned as well, around the importance of inside of the data center, normalizing signals so that you can kind of compare apples to apples, normalizing jobs. A big thing too is classification. Really, before you can take advantage of the flexibility of a job, you're going to need probably a human being somewhere along the way to say, this is a job that can flex and by these amounts in these dimensions, time and especially time dimension. So the GSF note talks about normalizing internally and then having good standards for external signals coming into compute clusters. And so I think that just crystallizes for me that we have enterprise customers, we've got coordinating organizations like GSF that are all starting to put focus into this space of making data centers more flexible. Truthfully, though, I do worry a little bit that it's still a slightly fractured space, and we're pushing in a lot of different directions, which is going to be necessary for exploring, but I'm not sure we're all rowing in the same direction yet.
That's interesting. I mean, anybody who's spoken to me for more than a minute knows that standards and interoperability are my favorite topic. But one of the things that has been the topic of conversation in the groups that I'm in recently is that there are a lot of sustainability standards being worked on right now. And we need to figure out the niche that each of us is working in and figure out how they all get sewn together. And figure out how this whole world of sustainability standards can actually interoperate with each other. I think the work that GSF has opened up with Silo is really important. I think it's going to lead to really important work. There's a lot of stuff that still needs to happen. I think this lays the groundwork for some really amazing work. The data center stuff has to happen. Stuff is a very technical term. But one of the things that we all know is missing is input from some of the larger data centers, which is slowly starting to come in, right? We've seen just little nibbles of interest from some of the people. I should say some of the organizations that people are interested often, some of the organizations that are involved in this. And I think with time, it might actually start to happen. For now, there's a lot of protection around image and money and who knows what else. And as some of that gets chipped away with lawsuits and God knows what else, it's going to have to happen. That's kind of how one of the ways that standards can emerge.
There's a lot of really great points there, and things that I try to be sensitive to as well when I do talk to skeptical potential customers. One thing that they'll raise to me as well is whenever you've got, a new standard, the software, carbon intensity, whatever it is, if you start quoting that now, and then the people who are iterating on this standard change something next year, then you can't quote the same thing that you did before, and your investors are going to say, "What's going on?" Or get confused. And so I know that has been stated as something that has slowed down certain enterprises with adopting standards. Is, oh well, once we start using them, then we're stuck with them, and we can't ever, just stop using them in the quarterly call after that. I don't know if I've got a good way to crack that nut, but it is a concern that comes up. I don't know if you've heard those ones.
I have. I think that there's a lot more flexibility in standards than most people think.
Yeah. One other thing I'll say quickly about that silo paper or concept from GSF. Making acronyms and stuff, and I definitely don't want to cast aspersions on anyone who made this acronym. I love everybody at GSF. But silo for a project that's meant to break down silos is interesting naming. But nonetheless, it'll help people remember that it's about breaking down silos, I hope, ultimately.
I will say the timing's impeccable. Silo is one of my favorite TV shows on Apple TV, and they released it at the same time as the latest season. So when I heard that, I immediately thought about the fact that there's another episode coming out tonight. So maybe that will also bring this home right now. If they could do some maybe collaborative marketing. But I will say one thing Silo, not the show, but the working group does well, is defining the silos or defining the layers.
Sure.
I think that's something that's incredibly important. You were mentioning, Tzviya, about we need to find our niches. And even in this article here, we see layers defined. And that's such a big starting point for people because it's so hard to define how a system breaks down into layers. And once you have your layers, you can start narrowing in and specializing and focusing on that layer. So I really appreciated that we got that out of this work.
Yeah, absolutely.
One other thing that I think you both have touched on earlier about, maybe I'd call it pressures, financial or regulatory pressures that really are the things that ultimately make people act. I think I'd throw another one in the mix, which is social cultural. And this is something that you see and feel in the US-Europe divide. But it goes beyond that too. I mean, I'm here in Mountain View and in the Bay Area, San Francisco Bay Area, and I like to think as a software engineer that we're very meritocratic and data-driven, and we'll only adopt a new software tool or package because it solves the problem that we are facing better than the last one. And a lot of times we do. But sometimes we just adopt something because Mark Zuckerberg talked about it on stage, and, oh, quick, everybody, this is the project that we have to emulate and model ourselves after. And so there are those times when, even as engineers, even when we're thinking that we're, wholly logical and rational, we really are, being dictated. We're dictating our technological choices like fashion choices ultimately.
Yes, absolutely. Yeah, I clearly.
So we have to make this fashionable. Once again, we need to just bring in the Silo partnership with Silo, and next thing we know, this is going to be the next fad. So.
Okay, Kate is advocating a collab.
I am
for it. There was one other article I had there as well, or one other, a little bit more of a marketing page than an article even, that I thought tied in though. It was a recent announcement from the company Neuralwatt. They, a few months back, had announced their cloud inference product, and then just more recently they announced the Flex variant of it. And there's Flex again. At least in this case, Flex does mean something along the lines of what we might be hoping for in this conversation. The Neuralwatt Flex concept is when you trigger an API request to their inference engine, you mention the model, and then if you're willing to flex the response somewhat, and I'll talk about what that means in a second, you just postbend a -flex. So it's Kimi K2 -flex, Quen 346 -flex in your requested model. And then what that does is they've got some guarantees in about what are the maximum impacts of that. But at a high level, what they're quoting is that roughly you're going to be experiencing a 35% cost reduction in terms of token rate. And in some of their testing so far, they found that 95% of the requests that they threw at their Flex system still started within 30 seconds. So we're not talking about you're delaying for days or anything like that. We're talking about a handful of seconds until they, in their system, they can dynamically adjust the frequency of the GPUs or something along those lines, I believe. But I thought that this was kind of an interesting one because it's especially more from the end compute user perspective, which I think is another thing that does get lost in this conversation a lot is Tzviya, you even mentioned this a moment ago, the owner versus renter mindset concept. This is another one where I come across a lot where people I'll talk at a conference with folks about, carbon aware computing and shifting some compute. And if they are in charge of a big GPU farm, they hear my incredibly expensive assets have to sit idle. I'm not going to do that, is what they immediately say. And what I try to tell them is that, okay, I get that. That's the owner mindset. You've got to amortize your quickly depreciating assets. Fine. But most of us aren't owners of large scale data centers. We're renters. We don't even necessarily think of ourselves that way. But if you have an AWS instance, if you even, just send queries to Claude or ChatGPT, you're technically a renter of compute. And we all can choose what we send when. And there's a lot more power there than we often think about, in part because it requires the bubbling and aggregation from the ground up. But that's another dimension that I've been thinking about a lot recently.
I am very happy with the owner versus rent analogy, and we'll be holding on to that for a long time. I work on a serverless platform where a lot of people are renting space on it. And I think that's a really good analogy for it. And one thing that I talked about at Green IO is that on our platform, we are CDN and we optimize for performance. So reducing latency as much as possible. In the future, it would be really cool to optimize, to let customers have the choice to optimize for sustainability and be routed to the greenest region. And I'm really going to pay attention to Neuralwatt here. I would love to somehow find out what percentage of users are using this flex choice and are motivated by that, because that gives a sense of, is this something renters are interested in? I have a Neuralwatt subscription, so right before this, I was trying out Flex, and I didn't notice its difference in latency. So I guess right now, or I guess an hour and a half ago, so 9:30 a.m. Pacific time is a great time where there was availability in the data centers in my region, but I didn't notice difference. So, and it was very easy. I just added Flex. It's not all the models. I did notice that. So I had to change the model I was defaulting to get one that supported Flex, but it was still the same response and pretty much the same latency. So I really love that feature. And I'm curious who else has done something similar, because it's a pattern that I want to continue to follow.
I was just going to say something that we've written into the web sustainability guidelines is not looking at this from the data perspective, but you can also write media queries like this just from a basic CSS perspective. You can write sustainable media queries where there's in the same way that you can do it for any other style sheet. But if there are ways to adjust it so that the user can choose the sustainable view or the heavy view, or whatever you want to call it, and let the user choose, then there's also leaving it up to the user. And I love the owners versus renters viewpoint, because really when we're looking at this, we're all renters of anything on a screen, because it's not permanent.
Yeah, I hope it can help us feel a little bit more empowered. We choose when we're entering and exiting the market. We don't always think of it that way, but that is very much what's happening. And the more that you think about grid carbon intensity and how wildly it can swing. I mentioned this briefly before, but just to put some numbers on it, where I am in California, it can be this nice sunny right now. It's probably down to about 50 grams of carbon dioxide equivalent. In the middle of the night, when we're more baseline and some fossil fuel energy, we're up to 350 grams of carbon per kilowatt hour. So these aren't little swings. This is like a 7x swing in terms of how much carbon dioxide you're emitting and making everyone else breathe. But at the same time, it's so distant. It's so, the cloud is already such a distant, abstract concept that, and then on top of that, energy and what a kilowatt versus a kilowatt hour is for so many people, it's rather abstract. And I completely understand how it's hard to track these things from end to end. I really love as well what you said, Kate, about, I love that you're playing with the Neuralwatt tool and starting to see how it fits into your usage patterns already. Another thing that it makes me think of is an example that I've come up with a few times or come across a few times. I'll talk with some colleagues that think, engineers don't care about sustainability. They're never going to do anything if their boss doesn't tell them to. I really don't think that's true. And the example I will point to is, a lot of us as software engineers, we spend time in our IDEs. And when we go to commit our code, there's the commit button and there's a drop down, commit and push. What if there's commit, push, and build green? And at that point, you send the job to the CI/CD pipeline annotated slightly differently. And maybe again, it can be delayed for some number of hours until a cleaner time for the grid. But you can give the engineer the end engineer the choice. They know when they need this build right now versus it's Friday at 5. I'm not going to see this until Monday anyways. So yeah, of course I'll build green. So again, this, I guess, is once again harping on the bubbling tools from the ground up theme, though, there's legitimate questions about how well we're able to aggregate our power and compute mitigation and emissions mitigation decisions when we're so fractured, though, too.
Well, this is kind of the conversation we had when we first met, Dave, right? Dave and I met at the Green IO New York conference, and we were having a conversation about sneaking sustainability in when you can. And I'll give credit to James Christie, who gave a talk about that at Green IO last year, about the whole concept of sneaking sustainability in. So this is how Dave and I met. But, anybody from GitHub, if you're listening, this is a great idea.
Hopefully so. And yeah, I think at some level it's just kind of empowering the people that are already in a good position to make the choices, but their, CFOs and their bosses don't know that the tools exist, don't know that there could be a benefit to the company, to society, if they were to pursue it, is my suspicion.
Absolutely.
So yeah, those were the articles that I kind of thought all fit into that flexibility, the very wide flexibility concept. There was one other one that I wanted to share, though, too, from Latitude Media. This is one about a company. I'm going to apologize up front. They're called Gridware. But when I was at Tapestry a few years back, we had a product called Gridware. So I'm inevitably going to mispronounce this at some point as Gridware. But their company is Gridware. And it's a company that had a pilot recently with PG&E. And this article follows a particular lineman who starts off really skeptical of Gridware's sensor suite. It's a platform to help keep track of assets out in the field, out in the fleet for a utility company. This might surprise folks, but this is something I got to learn while I was on the Tapestry team. The utilities, yes, this is a machine that's been more or less successfully operating for 100 or so years. But that's not to say that every bit of it is well understood and well accounted for and well documented. In fact, there are hundreds of grid assets, poles, transformers, capacitor banks in just the PG&E territory that exist that are not in any databases anywhere, or are in databases and don't actually exist. There's a lot of data quality issues that the utilities already are dealing with. And so this is a tool that helps in operations. I think one of the quotes that really stood out to me was the person who was a 30-year lineman, was really skeptical of these tools at first. And I think Kate, maybe you highlighted this as well, that he saw that it almost certainly prevented a fire in PG&E territory at some point after they were able to receive the warning through the sensor suite, the software from the sensor platform, and intervene much more quickly than they otherwise would have. And as those of us who have been tracking the saga of PG&E and their bankruptcy and all of the risks that they've taken on around vegetation and fire management and everything in the last couple decades, or that has been thrust upon them, from reality, I'm glad to see that they have some tools at this point to start to adapt and manage.
PG&E is Pacific Gas and Electric, which is the utilities company in California and Washington also. I'm not sure about that, but for people outside the U.S., that's where the electricity comes from. And there have been a number of forest fires that have fallen to them to handle, or partially to handle, in the last several years.
Thanks for fixing your West Coast, or my West Coast bias there. As well, there's confusion. One of the early articles talks about PG&E Portland General Electric. So there's even multiple PG&Es in the mix. But sorry, go ahead, Kate.
I was just going to say the note about using sensors as a prevention mechanism is very promising. And the fact that it was a grid manager who felt like the sensors were robust enough and that they weren't a headache, but rather something they were excited to install really does give me promise that this will be a lasting solution potentially. I think it's interesting how much grid resolution is human powered and human knowledge currently. One of my friends works on firmware for grid switches and power ups, and we were at the climbing gym and the power went out, and I just saw his head start working, and he was counting in his head. There was a flicker of light, and then he was counting in his head again. And he knew the local grid so well that he was able to explain to me, they remotely tried to repower it. That's why we saw the flicker. It failed based on where we're at. The grid is this size, so it'll probably take 4 hours for them to fix it because it's a lower priority region. And then we left the gym in the darkness. And that was just something that was in someone's head. And the fact that there are sensors that can maybe be, I'm sure there probably already are in that situation, but it just was such an example to me of how much knowledge and data there is in the grid. And just how if we centralize that knowledge, you can, maybe proactively get people to fix outages a little faster. And in that case, nothing would have happened faster, but maybe the sensors could have prevented what happened. Maybe it was a branch that was partially an obstruction that became a full obstruction.
I just found this interesting because this is something I have no knowledge about whatsoever, and it just never occurred to me that there's self-contained computers on telephone poles. In where I live in New Jersey, every telephone pole has what I thought was a solar panel on top of it, and I've been trying to figure out what this is, so maybe there's some amount of solar generation happening, but I'm guessing that there's some amount of sensors going on here as well. And we don't get power outages too often, but when we do, they tend to be fixed extremely quickly. We had a power outage sometime in the last 6 months. It was fixed within an hour, and it didn't affect a large area, so it wouldn't have been a high priority. It affected a few blocks only. And so they fix it very frequently. So shout out to PSE&G, my utility company. But I suspect that there's, I'm going to go outside and inspect the telephone pole on my front lawn later to see if I can figure out what's going on there. But I have a feeling that all those solar panels I installed within the last 10 years has something to do with sensors.
Sensors, there's more and more cameras out there too. I don't know if it's something along those lines, but hopefully it's sensors for utilities to better understand and manage their fleet. A couple other things that stood out to me were that the lineman who, to be clear, is now employee for this company, so he's kind of talking his own book ultimately, but he did highlight that they enabled a couple additional possibilities that hadn't existed before. One was that previously they really only had true faults, knowledge of true faults. Oh, the power stopped flowing from this point to this point. What they didn't have good insight into is events that lead up to that. High impedance spikes, things where a branch might touch the line and then burn, and then the impedance spikes a bit, and then so different situations that are more about dynamic operations that they could still see with these sensors. One other thing that they highlighted too is, for the folks that are there's millions of poles, utility poles in the country. This sounds really expensive. Maybe, but at the same time, it doesn't need to be the case that every single pole is instrumented either. They highlighted that for many poles, they're mechanically connected to their neighbors through a conductor, through the line, the wire across. And so in places where that's taut enough, you have enough ability to transmit the vibrations from pole to pole that you really only need every 2 or 3 poles, I think is what they were saying as well, as a cost-cutting measure, but still gaining that intelligence.
So interesting. So we had a running theme today of flexibility and its many different meanings. It's being priced and built into many layers, as well as being coordinated by many different communities. Do you have any closing thoughts, Dave, before we say goodbye?
I think that what you just shared there is a good setup to remind us that there are a lot of concepts and tools in flight that can look like different things. We talk sometimes about grid flexibility in one context, and then we talk about grid resiliency or the emissions of the grid in other contexts, but they really are all interrelated. And I think I think it's difficult to see a space where we are having a cohesive conversation. But I hope that conversations like this, the efforts that the GSF is partaking around building community, building a community lab space that they announced recently too, I hope that these are things that will at least give us those forums to bring the minds together, to break down those silos, even if it's as a part of a silo project.
Great.
I love that.
Let's just do a quick rundown of some upcoming events. CNCF's Environmental Sustainability Technical Advisory Group, or TAG, has been restructured and relaunched as TCG, Technical Community Group. Watch their site for details on upcoming meetings. We'll drop the link in our show notes. The next meeting is August 11th. Nikki Mandalecki, who we've had on the show previously, is one of the hosts. The Green Software Foundation's San Francisco Bay Area chapter is coordinating with Green.io for a possible crossover event in October. There's a Meetup page where you can find out more information, and we'll drop that in the links as well. That's it for this week's TWiGS. We've covered a lot of information about flexibility and awareness, carbon awareness, grid awareness, that sort of thing. Thanks for joining, and thanks Dave and Kate for the great discussion. If you want to keep exploring, check the links we've mentioned in the show notes, and you can visit podcast.greensoftware.foundation to listen to more episodes of Environment Variables. See you all in the next episode. Bye for now.
Thanks all. Been a true pleasure.
Bye.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.